Good morning. It is December 2nd, day 2 of our AP Calculus Free Response Question Advent Calendar. We've got a fun question from the 1999 exam today, but first we need to open up the second compartment from our chocolate Advent Calendar. So let's see, where is the compartment numbered 2 on here? Ooh, there it is, right by the Lindt Premium Chocolate and star there. So you just have to press in this little semicircle. I can even zoom in now. I've got a hang of this after our first chocolate yesterday. All right, so I press in there, then pull this thing open, something like that. Ooh, look at that. We got like this rectangle in here. Premium chocolate, it says. I am excited for this rectangle. The thing is, I like spheres as much as the next guy, but it's just such a typical shape for chocolate. I guess rectangles are too, but I don't know. I just prefer the rectangle shape. I'll put today's free response question on screen now while I enjoy this chocolate. You can read through the question. I don't know if this is caramel or what. Ah, look at that. Beautiful rectangle. It is not caramel. It is very good though. Is this ASMR? You like that chocolate wrapper noise? No, it's weird. Okay, I'll put it away. Let's do some math then. This is problem 4 from the 1999 AB exam. Let's read through it. Suppose that the function f has a continuous second derivative for all x, and that f of 0 equals 2, f prime of 0 is negative 3, f double prime of 0 is 0. We'll let g be a function whose derivative is given by the following equation involving f and f prime. Part A is to write an equation of the line that's tangent to the graph of f at the point where x equals 0. So we'll use point-slope form for this. Remember, the point-slope form of a line is y minus the y-coordinate. What's our y-coordinate? Well, we want the line to be tangent to f where x is 0. And we know that when x equals 0, f is 2. So the y-coordinate is that output of the function, which is 2. So we'll have y minus 2 equals the slope. What's the slope? Well, f prime of 0 is given to us. It's negative 3. That's the slope of a tangent line at x equals negative 3 on this function. So the slope is negative 3, and then x, of course, minus the x-coordinate, which is 0, and we don't even have to write that. So if we want to put this into slope-intercept form, which we don't have to do, but this is a really simple line, so perhaps we might as well, we get y equals negative 3x plus 2. So that is our tangent line. Let's move on to part B. Is there sufficient information to determine whether or not the graph of f has a point of inflection when x equals 0. We have to recall that a point of inflection is a point where the graph changes concavity, where the second derivative goes from negative to positive, or from positive to negative. In this case, there is not sufficient information. The only thing we know about the second derivative is that it is continuous, and when x equals 0, the second derivative is also 0. But we don't know the values of the second derivative to the left or to the right of 0. So we can't say if it switches sign, and thus we can't say if in fact x equals 0 is a point of inflection. Moving on then to part C. Given that g of 0 equals 4, write an equation of the line tangent to the graph of g at the point where x equals 0. So this will be a lot like part A. We'll use the point-slope form of a line in order to get our tangent line. Point-slope form is y minus the y-coordinate. We want this line to be tangent to the graph of g, so the y-coordinate is the output of g when x is 0, and we're given that is 4, so we have y minus 4. This has to equal the slope of the tangent line at x equals 0 multiplied by x, of course, minus the x coordinate, which is 0. We don't have to write minus 0. So now let's just focus on this slope. This slope is g prime of 0, so we just need to figure out what that is. We're given that g prime is this big, long expression. So let's just plug x equals 0 into that. G prime of 0 is going to be e to the negative 2 times 0, multiplied by 3 times f of 0 plus 2 times f prime of 0. And now we can plug in the known pieces of information here. E to the negative 2 times 0 is just e to the 0, which is 1, so this part doesn't really matter. 3 times f of 0, what is that? Well, looking at the question, f of 0, remember, is 2, so 3 times f of 0 is 6. Then we must add 2 times f prime of 0. F prime of 0 is negative 3, so 2 times f prime of 0 is negative 6. Thus, the derivative of g at x equals 0 is 6 plus negative 6, which is 0. And so we can plug 0 into that box. Thus, the right side of this equation is actually just 0. And so we can add 4 to both sides and find that the equation of the tangent line is just y equals 4, a horizontal line. Finally, let's move on to part D. Part D says, show that g double prime of x, the second derivative of g, equals this big long expression. And then we want to say, does g have a local maximum at x equals 0 or not? And we need to justify our answer. Okay, so this works out pretty nicely because once we take the second derivative, we'll find that it equals this, and then we can just plug x equals 0 into that second derivative. That will give us the concavity. If the concavity is downwards, so the second derivative takes on a negative value, well, that will tell us that in fact we have a maximum. And if when we plug x equals 0 into the second derivative, we get a positive number, that tells us it's concave up and we have a minimum. So let's go ahead and take the derivative of g. Remember that g prime was given to us as this expression, e to the negative 2x times all this stuff. So I'm going to go ahead and shrink our work for parts A through C, just so I can scroll up a little bit and we can see the whole problem while we work through part D. So to find g double prime of x, we'll just go ahead and take the derivative of both sides of this equation. That, of course, gives us g double prime on the left. And on the right, we'll need some derivative rules. First, notice that it's a product of functions, an exponential function times this sum of functions. So the product rule says the derivative of this will be u prime v plus v prime u. The derivative of the first function times the second function, so we'll start with that. The derivative of the first function is negative 2 e to the negative 2x, using a little bit of chain rule there. And then we have to multiply by the second function, which is just 3f of x plus 2f prime of x. So that is our u prime v from the product rule. Now we need to add v prime u. I'll do that on a second line so that I don't run out of room here. So let's think about the derivative of 3f of x plus 2f prime of x. That's our second function, which we need the derivative of here. And that's pretty straightforward. That's just going to be 3f prime of x, and then plus 2f double prime of x. And this needs to get multiplied by the first function, which is e to the negative 2x. Now we can factor out an e to the negative 2x from both of these terms. We can also then distribute the negative 2 through these parentheses and do some simplification. So here we are after factoring out the e to the negative 2x. We have e to the negative 2x, that's getting multiplied by everything. Here in parentheses, we have negative 2 times 3f of x, and negative 2 times 2f prime of x, and we have 3f prime of x, and we have 2f double prime of x. So now let's just go ahead and combine like terms. We can combine these f primes, and it looks like that's it. Negative 4f prime of x plus 3f prime of x is negative 1 f prime of x. And so now we can see that indeed this second derivative of g matches what we were supposed to get in the question. E to the negative 2x times negative 6f of x minus f prime of x plus 2f double prime of x. Now, to determine if g has a local maximum at x equals 0, we will determine its concavity by plugging x equals 0 into this second derivative. What is g double prime of 0? Well, when we plug 0 into the exponential, that's just going to give us 1, so let's not worry about that. F of 0, we know, is equal to 2. So negative 6 times f of 0 is going to be negative 12. Then we have to subtract f prime of 0. F prime of 0 is negative 3. So if we subtract that, we are adding 3. Finally, we have to add 2 f double prime of 0. F double prime of 0 is 0. So 2f double prime of 0 is just 0. So this is negative 12 plus 3, which is negative 9. Thus, we have a concave down function here at x equals 0, and so indeed, we have a maximum. And there is my written out conclusion, and that completes our solution to problem 4 from the 1999 exam. Let me know in the comments if you have any questions, and please consider supporting Wrath of Math as a channel member to help me create more high-quality calculus content. I'll see you tomorrow to continue our AP Calculus Free Response Question Advent Calendar. Thanks for watching.